All right, so now let's move on and do some problems with the eye. So we're going to do a problem for a far-sighted person and a nearsighted person. So for a far-sighted person, they can't see things well that are close by their eyes. So it's like your grandma reading a book. She holds it further away than normal. So normally your near point is 25 centimeters, but this person has a near point of 50 centimeters. So we want to know what strength of lens, so what's the prescription, 1 over the focal length, to correct the vision problem. I want to calculate both for someone who's wearing contact lenses and for glasses that are 1 centimeter from the eye. So what happens with a far-sighted person, is you want to take an object that's 25 centimeters away and you're going to move it so that the image is at 50 centimeters away. So you want the person to be able to hold the book the proper distance away, but their glasses are going to make an image of it 50 centimeters away so that their eyes will actually be able to read it. Okay, so our equation is 1 over f equals 1 over do plus 1 over di, just the lens equation that we had in Module 8. In this case, our do is going to be 25 centimeters and our di is going to be 50 centimeters. But it's going to be a virtual image, right? Because you want the book to be upside right. Virtual image is upside right. So we really want for them to have a virtual image. They want to see the book upside right. Okay, so 1 over f is going to be equal to 1 over 25 plus 1 over minus 50. So they get 1 over f is 0.02, but that's in centimeters, and the prescription has to be in diopters. I need to convert that into per meter. So I need to go from per centimeter to per meter. So I need to do this, 100 centimeters and 1 meter. I get 2 diopters. Okay, so this is a positive. Okay, so it's a converging lens. Positive focal length is a converging lens. Okay, so if you didn't want to do the conversions, we could have converted it initially. So we could have converted the centimeters, do to 0.25 plus 1 over minus 0.5 meters. And we would have got 2. And the unit is diopter. Diopter is the same as 1 over meter. Okay, so this is if they're wearing contact lenses. What do we do if they're wearing glasses? Well, if they're wearing glasses that are 1 centimeter from the eye, then what's going to happen is that di is going to go from being 50 centimeters to 49 centimeters. And we need to put minus. So let's do it the right way. Let's convert it to meters straight away. So minus 0.49 meters. So the prescription is 1 over f is equal to 1 over 0.25 minus 1 over 0.49. And now I get a slightly different number, 1.96 diopters. So sometimes you'll see this written as a general equation, generic equation. Let me write off to the side for a far-sighted person. That the prescription 1 over f is 1 over 0.25 minus 1 over the absolute value of the person's near point minus the distance between the glasses and the nose. So 1 over 0.25 is actually 4. So you sometimes see it written as 4 minus 1 over the person's near point distance minus the distance between the lens and their eye. So for the contact lens that we did initially, d is equal to 0. Little d is equal to 0. dn is their near point, which is the 50 centimeters. And for the eyeglasses, little d is 1, so I've got 50 minus 1, or 49. Okay, let's do for a nearsighted person. So a nearsighted person has a far point of 300 centimeters. So ideally your far point should be infinity, but for a person who's nearsighted, they can't see things that far away. So this person has a far point that's only 3 meters away. Okay, so we want to again calculate what power her lenses should have, both for contact lenses and for glasses that are 1 centimeter away from the eye. So we've got 1 over f equals 1 over do plus 1 over di. All right, so now we want our object to be infinitely far away, and we want the image to be at the person's far point. So we want it to be at, we sometimes call it df, their far point. Okay, so since we want the person to see the things upside right, we want it to be virtual, so we're also going to put a negative sign in there. So 1 over f is equal to 1 over infinity plus 1 over minus df, and 1 over infinity, divide anything by infinity, you just get 0. So for a person wearing glasses, a nearsighted person wearing glasses, their prescription should be just minus 1 over their far point distance. And again, we sometimes write that as 1 over df minus d, where d is the distance between the lens and the eye. So if the person is wearing contacts, the lens is right on the eye and d is 0. If they're wearing glasses, it could be 1 or 2 centimeters away from their eyeball. All right, so let's do the calculation. So for this person, her df is 300 centimeters. And let's go ahead and right away put that into meters, 3.00 meters. All right, so 1 over the focal length with contacts is going to be minus 1 over 3, because little d is equal to 0. So it's going to be 1 over 3 minus 1 over 3, sorry, and I get negative 0.333 diopters. And since this is a negative focal length, it's diverging. So most people who are younger who wear glasses are nearsighted. So if you look at your glasses, if you're nearsighted, you'll see that they're wider at the edge than they are in the middle. That's a diverging lens. That tells you that you're nearsighted. All right, what if they wear glasses? So she's wearing glasses where d is equal to, little d is 1 centimeter. So that's 0.01 meter. So in that case, 1 over f is equal to minus 1 over, now I'm going to do 3 minus the distance between her eyes and her glasses. So converted to meters, it doesn't make much of a difference, does it? It's just going to be 2.99. And I get negative 0.334 diopters. Okay, and finally, let's do a problem to find the focal length of a 5 times magnifying glass. So the magnification is 5, and the equation for the magnification of a magnifying glass is the normal near point distance divided by f. So n is equal to 25 centimeters. So I'm just going to do 25 over f is equal to the magnification. So 5 is equal to 25 over f. So rearrange that. So multiply up by f on both sides. So 5f is equal to 25. So f is equal to 25 over 5, or 5 centimeters. So for a magnifying glass, if your eye is relaxed, the magnification is just n over f, where n is 25. If you squint, you can get a slightly larger magnification. M is equal to n over f plus 1. So I could go from 5 to 6 if I held my magnifying glass up and squinted.